All right, to do this 2.7 lesson that you are watching my video for, to be able to solve equations, you really have to have a strong understanding of working with integers, which is positive and negative numbers. So I went ahead and put a quickie tutorial. You've already done a lesson on this, and if you already have a strong understanding, you can fast forward. But I don't know, a little review is never bad. So maybe hang out with me and go through this. All right, you can do different things to show how to work with integers, and some teachers will do number lines and that kind of thing. And in my head, I think of these, I don't know, I call them chips. Like there's positive chips and there's negative chips, and how many do you have more of, and how many more of them do you have, kind of thing. So here's how I visualize this in my head. I even say combining integers. I don't even get caught up in adding and subtracting. I just look at whether they're positives or negatives. So in this first example, I have a positive 5 minus 3. Well, that's second grade math right there, 5 minus 3. I already know what my answer is going to be, but I want to show you what it looks like when you do the chips. The 5 is positive, so I have 5 positive chips. The 3, this minus sign is making it negative, so I have 3 negative chips. And so when I think about combining these then, a positive and a negative will cancel out. And so I cancel and I cancel, and then I have 2 of these positive chips left, which means my answer is a positive 2. But in my head, I'm not drawing this all out, but I just think, hey, there's 5 positives, there's 3 negatives, so I have more positives because it's bigger. How many more? Well, it's 2 bigger than the 3, so I'm going to have 2 more of those. All right, and how you write this doesn't matter either. A 5 minus 3 ultimately is the same as a negative 3 plus 5, because the 5 is still positive and the 3 is still negative, and I still have more positives than I do negatives. In fact, I have 2 more positives than I have negatives. All right, let's look at this next one. I have a negative 8 plus 2. So in my head, I'm sitting there thinking, ooh, I have a whole bunch of these negative chips. I just have a couple of the positive chips. How many extras or how many more of the negative chips am I going to have? Well, those would cancel. I'd have 6 more of the negative chips. So when I combine a negative 8 and a positive 2, I'm going to end up with a negative 6 out of that. All right, next problem. And I'm just trying to do a little bit of each type that you might see. Sometimes what they like to do is, instead of putting a minus sign like we did here, it might be plus a negative, but that means the same thing. It's a negative 4. Whether you put it with a minus sign, which I typically do, or you do a plus a negative. The 4 is negative, and so I have 4 negative chips. But I have 8 positive chips, so I definitely have more. How many more? Well, 8 is 4 bigger than 4, so these are going to cancel, and I have 4 extras, and so I have a positive 4 for my answer. All right, next one. What if both of your numbers are the same sign? And so the second grade math again, 5 plus 3. Well, I know 5 plus 3 is 8, but this is what it looks like with the chips. Since all the numbers are positive, then I have, in this case, all the black chips are 8 of them, so I've got a positive 8. Now, if both of my numbers happen to be negative, like they are here, I have a negative 5, and then I put a minus 3, which is making this 3 negative. Okay, so all the chips are negative. So if they're all negative, they're all the same color, and I'm just going to add them all up. I've got 5 of them, I got 3 of them. I've got a total of 8, but they're negative chips, so it's a negative 8. All right, and then one last thing that you do need to kind of keep track of, and that's when you see this minus business going. So you can see I have a minus sign followed by another minus sign, and there's a parenthesis there, but there's not a number there. Anytime you go minus without a number, you change it to plus. All right, now, those are a plus, making this 3 a positive value because there's nothing in here that's negative anymore. So then I have a positive 5 and a positive 3. That's my positive 8 again. All right, one more like that. Here's my minus minus, I'm going to change it to a plus plus. So I can see that that's making my 3 a positive 3. But I started off with my 5 as a negative. So then I'm looking, I got a negative 5 and a positive 3. I have more negatives. How many more negatives? 2 more negatives. All right, that's what you're doing when you're adding and subtracting integers. And again, I just call it combining them. Also should probably talk about multiplying and dividing integers because we'll need to be able to do that. This is much shorter. All right, the gist of it is if you multiply like things, like both positives or both negatives, if your two numbers are positive or your two numbers are negative, when you're multiplying or dividing, it works there too, then your answer is going to always end up positive. If you multiply like things, your answer is positive. If you multiply different things, so that means you take a positive times a negative or a negative times a positive. If they are different, then your sign at the end is going to end up negative. All right, let's keep going. Let's do what you came here for. Let's do the equation solving. Okay, I'm going to start with some easy ones. We're going to gradually get harder. So we're going to start off with some one step. We call them one step. There's only one step to solving it. Now, when you're solving, you're trying to isolate the variable and get it all by itself. And what's different here than what we've done in the past is that we have an equals sign. And that equal sign is trying to keep everything balanced. And you have to keep whatever you do on one side, you're going to have to do on the other to keep it balanced on that with that equal sign. So when I look at this first one, here's the u. I'm trying to isolate it. I want to get it by itself to solve for it. So it's got this plus 8 that I need to be rid of. So I'm going to do the opposite. When I solve, I always do the opposite. So since it's a plus 8, what I'm going to do is I'm going to do a minus 8. Because a plus 8 and a minus 8 will end up canceling each other out. But I can't just randomly subtract 8 on one side of the equation. I would have to subtract 8 on the other side as well. So I would do a minus 8 on the left side of the equal sign. Now there I got to do a little bit of math. I've got a 7 minus 8. So think back to that first slide of the chips and stuff. I have 7 positive chips. I have 8 negative chips. I have 1 extra negative. So it's a negative 1 equals u. All right, there you go. You've solved it. U is by itself. U is equal to negative 1 if you like to write it the other way around. All right, let's see on this second problem. I'm trying to isolate the y, but this time the y is being multiplied by 8. Now, if I'm trying to isolate, I undo everything. So instead of multiplying by 8, I'm going to get rid of that 8 by dividing by 8. But if I divide the left side by 8, I have to divide the right side by 8 to keep it balanced. So the multiply by 8, divide by 8 cancel out. And I have a negative 56 divided by 8. That's negative 7. Oh, notice that the signs are different. If you multiply or divide different things, then your answer is negative. All right, let's try this one. Looks like, again, that I am taking this w, I'm trying to isolate it, but it's being multiplied by this negative 6. So to undo multiplication, I'm going to divide. Divide by negative 6. But I have to keep it balanced. You got to do it over here also. So the negative 6 divided by negative 6 is going to cancel out to a 1. 1w, or I'm just going to write it as a w, equals, over here, first thing I see is a negative divided by a negative. Those signs are the same, so my answer is going to be positive. And 42 divided by 6 is 7. All right, what do you think? That's a one-step scenario. You know, it's just going to get harder. Here we go. Okay, these are what we call two-term equations. And so to do the two-step equations. So to start with, I have a 2x plus 7 equals 13. I'm trying to isolate the x, trying to get this x right here by itself. there's two things going on. I'm adding the 7 and I'm multiplying by 2. Now I kind of think of you work your way towards the x. So you get rid of that peripheral stuff, the stuff farther away. So when I look at this x, between the 2 and the 7's way over here. Let's get rid of that first. It says plus 7. So I'm going to undo a plus 7 with a minus 7. But if I do it on the left side of the equal sign, I got to do it on the right side of the equal sign. So the 7's here are going to cancel, and I just have 2x. And on the right side, I get a 13 minus 7. That's a 6. Now remember, I said it's two-step. The first step was to get rid of the addition subtraction. Now what I'm going to do is get rid of this multiply by 2 that's going on. So I'm going to undo it with a divide by 2. Divide by 2. So now I'm left with x equals 6 divided by 2 is 3. And that is our solution. 2 steps. Get rid of your addition subtraction, then get rid of your multiplication. So let's look at this second one. 3x plus 8 equals negative 7. If I'm trying to isolate the x, I have this times 3 and I have this plus 8. Let's get rid of the plus 8. It's way over here, out of the way. Let's get rid of it. A positive 8, I'm going to undo it with a minus 8. But I got to do it to the other side. Now those 8's are going to cancel, and I'm left with a 3x equals, I got a negative 7, and I'm combining it with a negative 8. All the chips are the same color. They're all negative. How many negatives? 15 negatives, yes. Okay, now my x is being multiplied by this 3, so I'm going to divide by this 3 to undo that. That will get my x isolated, and I have a negative 15 divided by a positive 3. It's going to get you a negative 5. All right, one more. I'm going to go a little faster. I have a minus 11 that I'm going to get rid of first. I'm going to do plus 11, but I got to do it on the right side as well. The 11's cancel. I'm left with a 4x equals, I have a 9 plus 11. That's 20. Now I'm going to get rid of this times 4 by doing a divide by 4. Divide by 4. So x is equal to 20 divided by 4 is 5. All right, I have one more. Let's make it a little harder. Now we're going to combine like the last lesson that you did, the 2.5 lesson, with this solving idea. So what I want to do before I start moving stuff back and forth, I want to like clean it up. I want to condense each side individually first. I want to, if there's any like terms or something, I want to combine them. So in this first one, now you can do it on either side individually. So here's my equal sign. I'm going to do it over here on the left first. I have a 9y minus 5y. Those are like terms. I might as well condense those together. There's no sense in having both of those. 9y minus 5y is a 4y. Equals, now I'm going to look on the right side. Look, these are just numbers. They can just be subtracted. I don't need to keep them separate. Okay, now a 91 minus a 55, I don't know, probably going to have to do a little long subtraction here. 91 minus 55, borrow 1 from the 9. So 11 minus 5 is 6. 8 minus 5 is 3. All right, that's a 36. 4y is going to equal 36. Next step is to divide by the 4. Divide by the 4. So y is equal to 9. All right, so one more time. You're cleaning up each side as best you can, and then you do your two-step equation. Or maybe one step if you get lucky. All right, so let's look at the left side. On the left side, these are the like terms. This is not, so it's going to still sit there. But these two I could combine. I have a 2n minus 4n. A positive 2 and a negative 4. When I combine them, I'm going to have a negative 2n. The minus 6 is still there. equals. Okay, on the right side, again, I have like terms. They're both just constants, and a 14 minus 8 is 6. All right, now I got kind of like what we call a two-step equation now, because with the n that I'm trying to isolate, I have this subtraction piece and I have this multiplication piece. So remember, we're going to get rid of this minus 6 first by doing the opposite. I'm going to add 6. A negative 6 and a positive 6. That cancels. It's kind of like my black chips and red chips. They cancel. Now, if I add 6 on the left side of the equal sign, I have to add 6 on the right side. So what I'm left with is a negative 2n equals 12. Divide now to get the n by itself. So n is equal to, I have a positive divided by a negative, that's a negative, 6 in this case. All right, one more before I'm going to turn you loose on a little quiz. All right, we're going to clean up both sides of the equation to begin with. I see that I have two like terms here. 14z minus 13z. This one doesn't have a z, it's not a like term. But a 14z minus a 13z is a 1z. And really that 1 is totally optional and probably a little cluttery. Let's not even bother to put it. It's, oops, it's a z. But the plus 15 still sits there, equals 7. So now, to get the z totally by itself, I'm going to get rid of the plus 15 with a minus 15. And z equals 7 minus 15. We're combining here. I have 7 positives, I have 15 negatives, I have way more negatives, 8, in fact, more negatives. All right, hope you're still hanging with me. Hope it's getting easier for you. This is the little quiz I was going to have you do. Could you do each one of these by yourself? And then, so I'm going to have you pause the video, work these out by yourself, and then come back and I'll have the solutions for you. All right, go ahead and pause the video now. Check out the answers. Hopefully you agree with me. If so, I think it's time to start your certification. If not, look through my work and see if you can find where you might have gone wrong. All right, have a great day. See ya.